Hello, welcome to the course on Neural Science for Engineers. This is Srinivas Bhaskara, one of the TAs of this course. And if you look at the slide, we have been discussing about brain stimulation, and we have seen what are the different, what is brain stimulation, then we discussed why brain stimulation, then we have seen how the system of deep brain stimulation devices looks like, and the criteria for choosing electrodes. These are all we have extensively discussed, and we have seen hard versus soft materials, or it can be rigid versus flexible devices. We have seen advantages, disadvantages, all those things, right. So, now let us talk about device, how generally it is fabricated. Now, for us to understand in detail, I will take very basic example like this, okay, as follows. So, let us say I have to fabricate a device like this, something like this, okay, yeah, okay. Let us say this is a substrate, right. So, means this is not a hollow shape, everything, everywhere material is there, okay, everywhere material is there, okay. Now, for our understanding, okay, I consider this as a polyimide substrate, polyimide, okay. Now, this is a insulator, okay, polyimide does not conduct. So, where are the electrodes are? Let me change the color, let me put the blue, okay. So, let us say I have one electrode here at this area, and I have one more electrode at this area. Now, for our understanding, I have just simply considered two electrodes, okay. So, I have a contact pad like this, and I have a contact pad like this, and okay. So, these have dimensions, okay. So, these are square, rectangle, or whatever it is, right, and there should be contact interconnects, right. So, interconnects, okay, something like this from here to here. It could be in any fashion depending on the application of whatever we are talking, right. So, for this is a basic example, okay, this is a basic example. We can have different architectures depending on the application, right. So, because there are a lot of research is going on, we are talking about, people are talking about omnidirectional, directional and all those things, right. Now, here one part one should understand is, right. So, wherever the electrodes are there, okay, wherever the electrodes are there, that electrodes only need to be exposed, correct, no, because on the brain, right. So, let us say this is the brain top view, okay, top view of the brain. So, you put the device, okay, if you put the device, how does this device looks like this, correct. Now, here in this my region of interest is only this area, only this particular area, okay, to be precise this area, that is it, only that particular area we need to stimulate. Remaining areas and all we do not want to stimulate or record or whatever it is, okay, right. So, only that area need to be exposed, only the electrodes area, only the electrodes area need to be exposed. Remaining everything means see this, and if you follow the pointer, okay, let me use a laser pointer and then explain you. If you see this is electrode area, whatever I am pointing right now, that area should be exposed. This area, this interconnect line is there, no, this area should not be exposed, otherwise, right, what will happen otherwise? Now, see, otherwise what will happen? So, if I draw like this, okay, this is how it looks like, no, means this area gets exposed, this area gets, if everything is exposed means everywhere the stimulation takes place. No, we should not supposed to stimulate the unnecessary area, unintended area. Wherever it is intended, that area need to be exposed, that is all. Only the, this is called, this is contact area, okay. Contact area, only that needs to be exposed. Interconnects and all should not be exposed, okay. And this area, contact pads. What about contact pads? These contact pads also need to be exposed. Why? Because this has to go for another electronic circuits, right, electronic circuit board. So, understood na? So, this is the requirement, okay. So, let me erase everything, I will redraw, and then now you have understood the requirement, correct. So, we have a device something like this, right, on the device. So, there is an electrode here, and there is an electrode here, and these are the interconnects, okay. This should not be exposed, keep that in mind, this an interconnect area should not be exposed. Correct. So, how the device fabrication happens is, okay, this entire thing is a contact, okay, or a let us say for example, I told you that this is a polyimide, right, polyimide, and this is a, I can say for example gold, okay. Generally we cannot use only gold, we can use titanium or gold, whatever it is, right. So, let us see how the process flow looks like. Now, we understood that is no requirement, no, right. So, I talked about polyimide, and this polyimide does not come just like that, this comes as an liquid, okay. So, what is that liquid? Polyamic acid, right. So, directly we cannot work with the liquids, okay. We have to make them, like a solid or solidify that or cure it, the terminology is cure it, then we have to go for process steps. So, now you take this silicon, first step is considering a silicon wafer, okay. So, here second step what we do is, over this silicon wafer we drop cast the polyimide, okay. So, you have a polyimide bottle and you drop cast it, okay, and then you spin coat it, spin coating, you do spin coating, then followed by curing, okay, at some certain temperature, like for example, some processes we can do at 80 degrees, 250 degrees or 360 degrees, whatever the requirement is. Then it will become like a solid, it will stick to the silicon wafer, okay. So, now your polyimide is ready, okay. So, polyimide, instead of writing all the time like this, I just write Pi, okay. So, that is what is the point mentioned here, polyimide spin coating followed by curing, right. So, now what is the next step? Now, here if you see photoresist coating followed by lithography, right. So, let me go back to this part, right. So, what happens is, for example, when you use any deposition technique, okay, any deposition technique. So, if I take this wafer, okay, so the gold or any material that you are want to deposit, metal and all, it will be deposited everywhere, it will be deposited. Okay. So, more details about this and all, right now in this session we will discuss about the basics of it, okay. More in the discussion will be done later on, okay. So, this is how the entire gold will be deposited everywhere, all over it will be deposited, correct. But I do not want it all over the device, correct. I want only this kind of structure, only this electrode here, and there is a interconnect line here, and there is a contact pad here, only this part I do not want all over this like this whatever I have shown here with the wafer, right. So, what we do is generally okay, in terms of side view, okay, let us talk about this, let us discuss this in the side view. In the side view what happens is, from this angle if you look at, right, you have a polyimide, this is polyimide, right. On top of that, okay, so let me change the color. On top of that you have two contact pads. Okay, this I cannot show everything. Okay, I can also show like this, but let's just restrict our discussion to only this one. I do not want to make these things complicated. Okay, if you look at this from this side, let us assume that you are not seeing these electrodes and all. Okay, just see this contact pads only, so that it is very easy to understand. Okay, so this is a metal. Okay, or this is whatever I was referring to, titanium or whatever the material that is. Okay, so initially what will happen after deposition, once you use deposition technique, right. So, you will have a polyimide and along with that everything will be deposited like okay. So, what people can do is, if you deposit everything, right, then you have to etch unnecessary metal, you have to etch it. So, using, right, there is a process. Okay. So, there is a process called, first you deposit photoresist, okay, or spin coat the photoresist, then you need to do baking. Okay. There is a whole steps are involved in that. Okay. So, in this what how to etch anything is, first you should do something called lithography. Okay. First you do lithography, create a pattern, then you can etch it. Okay. So, I am just simplifying the things. Okay. Understand that these are not the ultimate steps, I am just simplifying, so that we just need to see how these are fabricated just as an example. Okay. So, what you do is, this is a photoresist, right. So, photoresist has been spin coated and you perform something called lithography. Okay. So, assume that you know the steps of how to create lithography and all. Okay. So, lithography is nothing but process of transferring the pattern, that is it. So, you want to create this pattern, right, this kind of pattern. Okay. This let me take the pointer. Okay. You wanted to create this kind of pattern, right. Okay. So, you do not want the entire gold to be deposited everywhere. So, what you do is, initially you coat this with a photoresist, okay, all over. Okay. Then wherever you want to deposit the, okay, let me explain this in detail, let me clear this. Right. So, this is erase this stuff. Okay. This is the structure, this is the substrate that I am looking at, On the substrate, now what you do, right, you spin coat the photoresist. Now, you spin coat everywhere. Now, this green color thing is a photoresist and there is a process like pre-baking and all that should be done. Okay. Understand that these are everything are understood already. Okay. For example, if you are not understood, that will be covered on. Okay. Anyways, no problem. So, there is a photoresist that is deposited. Now, you want to etch the photoresist from some areas. Okay. So, in some areas wherever you do not need photoresist, means you want the gold to be there. Okay. So, this is the area. Okay. So, wherever I am showing, okay, understand that photoresist has been removed. Okay. There is a developer, photoresist developer. What you do is you need to remove, just like that you cannot remove it, there is a process. Okay. You should do something called lithography, this is what I am referring to. Okay. Now, photoresist is there, photoresist is removed at these areas wherever the black is there, no, wherever the black regions are there, in that area photoresist is somehow removed, right. Now, you look at from this angle, right, what will be there now, if I write the side view, right, the bottom layer is polyimide, right. Then what I have? I have some photoresist, correct, because I did lithography on this photoresist, right. So, there is a whole steps that are involved in this. Now, wherever the pattern I want to see, wherever this pattern I wanted, this black pattern, okay, that is exposed, right. Now, you do any deposition techniques. Okay. So, you can go for PVD technique or CVD technique, whatever the process allowed, okay, and then deposit. Now, what will happen? Now, let me take another color. Now, you want to deposit the gold, right. So, when you deposit, this gold will be, this gold will come and sit here. Okay. So, in this place gold will come and sit, okay, and gold will be coated everywhere here also. Okay. So, then what you do after this, you do not want the gold to be all over, right. Now, this you keep it in a lift off, for this is process is also called lift off, okay, solvent. Okay. So, then this part will be removed, because when you put this in acetone or photoresist stripper or techno strip or whatever it is, okay, this photoresist will be etched. Over this photoresist already gold is there, correct, automatically this also will be etched, this also will be etched, this also will be etched. What is left? This pattern remains same. So, let me draw it neatly here. So, what is left is I have this device. Okay. So, if the photo you after dipping it in the lift off solvent, means for example, acetone, if you keep it, then what will happen everywhere, this photoresist will be removed. What is left over? Sorry, these are circular, right, these are square. Okay. This pattern will be left, okay, and everything else is removed. Okay. This is how you achieve it. This is also, this is called as a lift off. Okay. There are many methods of creating this kind of patterns, okay, but understand this, we are talking about lift off technique, right. So, what you do here is, okay, this is the C step. Okay. So, first you deposit the photoresist, then create a pattern, okay, and because for that mask everything, many things are required. Okay. I am not discussing going in detail about it, I am just trying to explain the brief overview of how the process takes place. Then we go for something called as, you deposit the metal and then do lift off. So, once you do lift off, you will achieve this. This is what we have discussed in the last slide, correct. Once you do lift off, you will achieve wherever whatever you wanted. So, then now one more thing is what I said, now you just did lift off, but this metal is exposed, right. Let me show the pointer, let me take the pointer, this part, this entire thing is exposed, correct, interconnects are exposed. We have to, what we should do is, we have to insulate them. Okay. So, how to insulate them? So, because we already know that photoresist is a insulator, correct. So, what we do is, you again spin coat, similar step whatever you have done here, spin coat with respect to this, right. Now, with that what happened is, again all over photoresist polyimide has been deposited all over, coated. So, what you should do? You need to expose these areas, expose these areas, expose this area. this particular area has to be this particular area, this area that needs to be exposed, right. So, that we can do by using something called as reactive ion etching, okay, RIE. Okay. So, we have something called as wet etching techniques, where we use chemicals and all other things in liquid form, and we have something called dry etching techniques, where we use chemicals in gaseous form, all those things, right. And this is how I have obtained now, I have created, I have exposed by using RIE. This area and this area I have exposed during RIE, correct. Now, what is the other step here? There is something called as, you see this RIE for device separation. See, whenever I fabricate the devices, I will not go for only one device, no, because I have entire wafer. Okay. On this wafer, I have n number of devices like this, n number. Okay. So many like that will be there, okay, depending on what is the size and what is the size of this guy and all. Okay. So, I will have a mask, okay, using which I can do lithography, so that I can there is something called mask, okay, using which, okay, we can do we can transfer the pattern, okay, and do lithography. Okay. In lithography, one of the most important critical thing is a mask, design of a mask, that has to be designed properly, right. So, using that mask, we can create the device separation, and finally, what is the device that you need is a polyimide, right. Now, if you see, you have a silicon here, now you have a polyimide here, now here again you have a polyimide, okay, and these are could be contact pad. Now, if you look at this guy, this is covered within the insulation. What do you think is that? Interconnect. Okay. I am just showing the side view, no, that could be interconnect. This could be again a contact pad or whatever it is, contact pad. Are you getting it? So, then there is something called as peeling off devices from the silicon substrate. Okay. So, we can peel off using the, or we can cut it nicely by using a surgical blade kind of thing, right. It depends about whatever it is, right. So, to iterate again, we have silicon wafer here, and silicon wafer, we are on silicon wafer, we are spin coat, we are drop casting polyamic acid, and we are doing spin coating and curing. Then we are going for lithography to form to create the patterns, and now the patterns are created, but I do not want to expose the entire electrodes or entire electrical contact like this. Okay. What I mean to say is this entire thing, like from here to here I do not expose, I want to expose only the electrode area and the contact pad area. Okay. So, what I do, again I use a insulation layer. Okay. So, this is what is mentioned here, this is for insulation. Then once you are insulating everything. Okay. You are insulating electrodes also, you are insulating contact pads also. So, what I do some kind of etching, in this case RIE etching, to remove this particular polyimide in this area, okay, so that these could be connected, okay, to the electronic circuitry later on, right. So, this is what is explained again here, and this is for separation, device separation, because I told you not all the you cannot fabricate a single device, we can go for a few tens to hundreds of devices at a stretch, right, in a single silicon wafer. Okay. That is why there is a device separation step is required, and then you can peel off that particular devices. You can separate the devices, or you can peel off the devices from the polyimide substrate. Are you getting it? So, but if you look at it here, there is a small mistake which I am pointing it out. Okay. So, make a note, pay attention to this. So, here if you look at this, right. So, when you peel off Okay. So, one more thing what we generally do is we can make a fine surgical knife and then we can cut this, so that we can cut the entire thing. Okay. So, here it looks like there is a connection. Okay. So, but there is no connection as such. Okay. So, right, what I mean by is there is no connection as such. So, you are peeling off the entire thing, I mean you are separating between the devices. Okay. So, there is no polyimide here, okay, it is empty, are getting it. So, it is like that. So, then you peel off the devices, right. Peel off means taking off from the silicon wafer, that is all. Okay. So, that is how a device this process flow is. Okay. So, this see I have just discussed about different steps that are involved. I just discussed about different steps that are involved in the process, and we have not gone in detail. Okay. So, that will be discussed later on. But the point is I wanted to tell you that these are the different steps that are involved. Okay. So, lithography is a whole complete step. Okay. And spin coating, there are different steps that are involved in that. Okay. RPM is there, I mean how fast, with what speed you are rotating the spin coater and all those things. So many things are matters. Okay. Mask is there in lithography, so many things are there. Okay. So, I just bypassed all those things and then briefly touched upon what exactly that looks like, so that I wanted to give a feel of how a device can be fabricated. Okay. So, that you can keep in mind. And next step is, once your these things device is ready, then we have to go for electrical connection, right. So, now I will just give you what are the overall if at all you want to work in as a neural science engineer, or you want to work in this kind of biomedical related work. So, what are the requirements that you need? Okay. If you look at this is a device that we are talking about. Okay. Whatever is the zoomed in area, that is a device, and for fabricating that device you should have first of all there is something called clean room. Okay. And this is the place where the categories depends on how depends on, let us say for example, I say clean room, okay, 100, clean room 1000. Okay. So, what does it mean is it shows the purity of that room with respect to some dust particles or particles of some size which are less than 0.5 micron or greater than 0.5 micron, something like that. Okay. There is a whole lot of things about clean room, and there are different deposition techniques we discussed about, I mean not discussed, we just briefly touched upon PVD, CVD and all those things. Then we talked about lithography is required, etching is required, inspection using a microscope, you inspect those sizes and all those things. Okay. So, with this, if you have knowledge about all these things, then we can fabrication is done. Then after the fabrication we have to characterize it. Okay. So, this is cyclic voltammetry, voltage transients, electrochemical impedance spectroscopy, we have discussed briefly about that also. Okay. These are electrochemical characterization techniques. Okay. We have discussed already why so this is so important to do. Okay. So, next is, if this is done, this is done, next is these are the real electronics circuit. Okay. Now, if you look at this diagram, okay, or representative picture, you have these electronics as connected as a backpack. Okay. Right, and we do wirelessly. Okay. Wireless, this enables wireless stimulation. Okay. Generally what happens is, okay, we can have a connector here. Okay. Now, this is just to represent the surgery of what it takes. This is like a skin, then this is dental cement. Okay. Oh, sorry, this is a skin, then this is a dental cement, and this is a skull bone. Okay. Now, there is a connector to this, and then it will go to the through a wire. Okay. There it will go to the electronics board, right. So, what I mean to say is, now you have electrode here, correct. and there is a connector here, the contact pads are here. Now, you put a connector to this. Using this connector, there is a wire here, this will go to the electronics board, okay. And this board is controlled compute, you are using a computer and all those things, okay. And this is a wire. So, what happens with the wire is we are going to do something called as gate analysis, okay. Gate is related to something called as movements, like how fast it is moving and how slow it is moving and all those things, right. When there is a wire, okay, then the problem here is it cannot move properly, because when somebody ties you something, some rope or something like that, you cannot move freely, right, that is how it is. So, the idea is people are going for a wireless stimulation, where there is a some kind of communication happening wirelessly, right. And of course, it is a very complex circuitry, lot of research is going on in these areas as well while designing these different blocks, okay. So, in the work that in some of the works that we found out, like we can use the current mirror blocks, why current mirror blocks and all we will discuss, and we have BLE devices, and we have PSOC microcontrollers, and we have LabVIEW programming, okay. We need to use all these things to set up this particular guy, okay, that electronics board, and this electronics board will be very less in weight, okay, such that rat can easily carry that while doing a behavioral analysis, okay. So, we will briefly look into the current mirrors in the next lecture. Thank you.